Just like we never get 100% confidence in a confidence interval, we also never completely eliminate the possibility of making an error in a hypothesis test. In this section, we establish some language to talk about the types of errors that can occur. And the types of errors are directly related to whether or not we rejected the null hypothesis in our formal statistical decision. So this table here is taken from the textbook and shows the language that we use. As we can see here, there is a type 1 error in the event that we reject the null hypothesis even though it was true, and we have a type 2 error in the event that we fail to reject in the event that the null hypothesis was false. The other two cases in this table don't describe an error if you reject the null hypothesis and the null hypothesis was false. Those are consistent. That means that you made the right decision, and similarly failing to reject when in fact the null hypothesis is true is also describing making the right decision. We don't generally know that we've made a type 1 or a type 2 error. We just need a language to discuss them so that we can further the subject. So let's take a look at an example of the effects of artificial sweeteners on weight loss. Suppose we did a randomized experiment on these effects and our null hypothesis was no impact. That's a fairly standard null hypothesis. And our alternative hypothesis is that the sweeteners improve weight loss. So it looks like kind of a one-sided alternative hypothesis. For these hypotheses, we conduct an experiment and we get a p-value of 0.02. So the first thing we need to ask ourselves is, if we're looking at the 5% level, let's make a formal statistical decision. Do we reject the null hypothesis or do we fail to reject? Because our p-value 0.02 is less than 0.05, which is the equivalent of 5%, we would, in this case, reject the null hypothesis, meaning that we find statistically significant evidence in support of the alternative hypothesis. It looks like we do have evidence that artificial sweeteners improve weight loss. If we rejected the null hypothesis, the only type of error that is possible is a type 1 error. So this answer is automatic based on the fact that we reject. Now, describing what an error of this type means in context requires two components. The two components are that we reject the null hypothesis. We need to say that in context. And that, in fact, the null hypothesis is true. So we need to also say that in context. A correct description has got to have both of those pieces. So let's write out in context what that means. To reject the null hypothesis means that we have found statistically significant evidence in support of the alternative hypothesis, which we can just copy the wording down exactly as it is. We have found statistically significant evidence that artificial sweeteners improve weight loss. So we're only halfway done here, right? We've found statistically significant evidence that this statement here is equivalent to saying that HA is true. Now the second half of this, we can then put a comma and say even though. So we've found statistically significant evidence that the alternative hypothesis is true, even though in reality the null hypothesis is true. So we want to look now at the null hypothesis and put it in words, which we already have it in words here, so we can just copy down these words. So even though artificial sweeteners have no impact on weight loss. And we can just say even though they have no impact on weight loss, because we've already established that we're talking about artificial sweeteners. So the simplest way of thinking about what the bare bones statement is we say we find statistically significant evidence that HA is true, even though H naught is true. And that describes an error. If we only have half of this, like say we only established that we found statistically significant evidence that artificial sweeteners improve weight loss, we haven't described the error. We need to say what we believe is true and what is actually true to make it clear that we're describing an error. Now let's consider another example with a larger p-value. Suppose we're interested in a randomized experiment on the effects of exposure to sunlight on depression. So perhaps in this experiment people were exposed to artificial sunlight, or perhaps they were told how much time to go outside during the day. We can imagine how this experiment might have been run, but we don't have to get into the details of those right now. So our null hypothesis is that there is no impact, a very standard null hypothesis, that sunlight has no impact on depression, and our alternative hypothesis is that exposure to sunlight reduces depression. If the p-value from this study was 0.17, then at the 0.05 level, or the 5% level, we're comparing 0.17 to 0.05, and we can see that it is in fact greater. And so we clearly fail to reject. This large p-value does not give us statistically significant evidence that HA is true, meaning that exposure to sunlight reduces depression. Given that we failed to reject, the only type of error that is possible is a type 2 error, so this part of our answer is automatic, type 2. To say what this means in context, we need to establish both parts of this. Do not reject or fail to reject H naught. And that H naught is false. Right? The type 2 error is the intersection of these two pieces, so we also need to establish in context that H naught is false. It's a little bit easier to think of this in terms of HA being true. So we can, in words, say when we fail to reject, it just means we didn't get statistically significant evidence for HA. Even though HA is true, we're going to now put that into words. So the first half of this is our fail to reject H naught, and we're saying we do not get statistically significant evidence of HA. So again, exposure to sunlight reduces depression. That's exactly our HA. Then we put in the even though, and we say the second half of it. Even though, in fact, HA is true, exposure to sunlight does reduce depression. We don't have to say those exact words again if it's obvious and we can summarize it. We don't get statistically significant evidence that exposure to sunlight reduces depression, even though it really does. So in this case, I think it's pretty clear what we mean by it and does, because we've just said the exact words that we mean here. But if you're going to take a shortcut like that, reread your sentence and make sure that you really have demonstrated the important information.